let's talk about stoichiometry and gases. First of all, let's review. We've talked about the molar mass of a gas at STP. The volume of 1 mole of gas is 22.4 liters. So if we know volume, we can divide by 22.4 liters per mole to get moles. If we know moles, we can multiply by 22.4 liters to get volume. 22.4 liters per mole to get volume. All right, this presents some interesting aspects about stoichiometry when we talk about gases. If you are talking about, for instance, if you look on the page in your textbook, your packet that says stoichiometry of gases, apparently I don't have page numbers in this, but it's closer to the end. The third problem talks about propane, and if we read through the problem, it tells us we have 3 liters of propane, and it's at standard temperature and pressure, and we want to know volume of water vapor. So we're going to start with, I'm going to actually switch and do 3 liters of propane, and we're going to be ending with volume of water. Okay? So if we follow this idea, first changing to moles and then going through the mole ratio, we would start out with 3.0 liters of propane. We need to change that to moles, so we divide by 22.4 liters in 1 mole. Then we look at the ratio of propane to water. 1 mole of propane to 4 moles of water vapor. And it's asking for volume, so we change back by multiplying this time by 22.4 liters in 1 mole. Now, does anybody see it? In this equation, we've got 22.4 liters on both sides. This is kind of a cool thing. If you're doing stoichiometry of gases and you're going volume to volume, unless the conditions have changed, the pressure needs to stay the same, the temperature needs to stay the same, you don't need to do any conversions. You can just go straight to the mole ratio. So if we look at the next one, we've got 3,500 liters, so yes, let's look at the next one. And we're going to go to volume of oxygen. We should be able to do this. Let's see if we can. 3,500 liters of carbon monoxide. There are 2 moles of carbon dioxide for every 1 mole of oxygen produced, which would give us half of 3,500, which I should be able to do in my head, 1750. All right, now let's try it using all the other information that's in there, all right? Because it says, hint, calculate the moles. So let's use PV equals nRT to find moles of carbon monoxide. PV equals nRT. If we want to know moles, it's PV over RT. So we'll take 3,500 liters times that's our volume. Our pressure is 0.976 atmospheres. Our temperature is 19.8. 19.8 plus 273. We get 471. And we get 0.0821 liter atmospheres over mole Kelvin. and that will solve for moles. So then we would apply the mole ratio, 2 moles of CO to 1 mole of oxygen, and then we've got to find volume again. Since it's not an STP, we can't just assume 22.4, but we can plug all this information in. Again, volume, if we use PV equals nRT, volume is equal to nRT over P. So we know moles, we've just calculated, so we need to multiply it by 0.0821 times, oh, it's not 471, I can't add. 273 plus 19.8 would be 292.8. And we divide by pressure. Once again, look at what happens. These two are the same. These two are the same. These two are the same. So all you have to do again is go liters times the mole ratio. Okay? So that's with volume to volume. Now, if we go to this page, gas and stoichiometry notes, it gives you the PV equals nRT. These are starting you with something other than a volume, or ending you with something other than volume. So let's look back at our mole bridge. We've already done in class starting with grams, we've done starting with particles, and we've done volume of liters going in using a liquid. Now we're going to talk volume of gases. We're going to put in divided by 22.4 liters per mole, or if it's not at STP, because remember this has to be STP, you simply use ideal gas law to come up with moles. And the same going backwards. Okay? So, what's our unknown here? Or known, I'm sorry. We know that oxygen is at 1.8 liters. And we want to solve for liquid ethane volume. Or we want to solve grams. Okay? Can't solve this without a chemical formula, so we first need to do combustion of ethanol, which means it's reacted with oxygen. Combustion is always carbon dioxide plus water. We need 3 times 2 is 6. There's 6 hydrogens. We need a 2 here. 2 times 4, 2 is 4 oxygens plus 3 oxygens. That adds up to 7. We have 1 oxygen here, so we need 3 there. All right, so we're going to start with what we know. We know that we have 1.8 liters, and we need to find moles. Remember that moles is equal to PV over RT. So we have our volume, we have our pressure, we have 0.0821 liter atmospheres over mole Kelvin, and our 273 plus 22 would be 295 Kelvin. So that takes us to moles of oxygen. Now we're going to solve for propane. So for our ratio, we have 3 moles of O2 will give us 1 mole. I can't write. Of ethanol. Now it wants grams of ethanol. So we have done this. We have gone, oh, I should do yellow, from here to here, And now we need to go back, but we want to go to grams. So we need to multiply by the molar mass of ethanol. Molar mass of ethanol is 46. And if we plug all that in, 1.8 times 2.5 times 46 divided by 821 3, I put that all in parentheses, 2.85 grams. All right, next one. We're starting with grams this time. So if we look at our mole map up here, this time we're going to start with grams of zinc, and we're going to calculate volume of hydrogen gas. So we'll go from here to here. Okay. First we need an equation. Zinc plus hydrochloric acid gives us hydrogen gas and zinc chloride. We need a 2 here. We're starting with 12.5 grams of zinc. To change that to moles, find my periodic table. It's 65.39. Our ratio of zinc to hydrogen is 1:1. So now we have to change to volume. We can't use 22.4 because it's not STP. So we know moles. We need to find volume. Volume is equal to nRT divided by P. This already calculates moles for us. 0.0821 liter atmospheres over mole Kelvin. R times T, 27 plus 273 is 300. And the pressure is 1.5 atm. Atmospheres cancel, not potassium, Kelvin cancels, moles cancel, that should be zinc, grams cancels, and we should have an answer in liters. All right, the answer is 3.13 liters, assuming I'm doing my math correctly. Okay, so what I need you to do then to practice is go ahead and go to this page, stoichiometry of gases in the packet, and calculate through those 2 pages. And I will get an answer key with all this scanned and put in the computer here as soon as I can. Thanks, guys.